How important is mental health, and how can technology lend a hand in its improvement? The answer is immensely. In our bustling world, mental health has taken center stage as a critical aspect of overall well-being. The rising concern for mental health is not unfounded. With the myriad of unique experiences and struggles each individual faces, the need for personalized care is more pressing than ever. Enter technology, or more specifically, artificial intelligence. AI holds the potential to revolutionize mental health care, paving the way for personalized, efficient, and accessible solutions. Imagine AI-driven therapy and mental health support systems that can understand and respond to your individual needs effectively. It might sound like science fiction, but it's not. It's a reality that is gradually unfolding thanks to the relentless efforts of researchers and scientists. Now, to understand how AI can help, let's delve into something called the McGinty equation. What exactly is the McGinty equation, and why does it matter, you might ask? Well, let's dive in and simplify this complex yet fascinating concept. At its core, the McGinty equation, also known as MEQ, is a mathematical formula represented as piece xt equals sign psqft xt plus ps fractal xt dmqs. Let's break that down. The piece xt part of the equation represents the state of a system at any given point in time. This is the overall picture we want to understand. Then we have psqft/xt, which stands for the solution of the free quantum field theory. Quantum field theory, or QFT, describes how particles like photons and electrons move and interact. It's the language of the microcosm, the tiny world that's smaller than an atom. But what about the plus sign? That's where things get interesting. The next part of the formula, piece fractal xt dmqs, represents the fractal nature of the system. Fractals are patterns that repeat at every scale, no matter how much you zoom in or out. They're everywhere in nature, from snowflakes to tree branches to the veins in your body. The D, M, Q, and S in this part of the equation are parameters that describe the fractal's specific characteristics. These could include its dimension, mass, charge, and other properties. So, by combining the concepts of quantum field theory and fractal systems, the McGinty equation provides a way to understand complex systems that are both tiny and infinitely complex. It's like having a map that can guide you through a forest and also show you the details of each leaf. But here's the thing. The McGinty equation isn't a static entity. Over time, it has been modified to account for other factors, like the effects of gravity on a quantum field. This is represented by the added term piece gravity, XTG, where G characterizes the strength of the gravitational force. But the McGinty equation doesn't stop there. It has been modified over time. Be ready to learn about these fascinating modifications in the next scene. The McGinty equation went through some changes. What were they? Well, if you remember the original McGinty equation, it was a remarkable blend of quantum field theory and fractal systems, represented as P(t) equals sign Psqft xt plus piece fractal xt dmqs. However, it underwent a significant transformation, which introduced another component, piece gravity xtg. This new term, piece gravity xtg, is far from a simple addition. It represents the perturbative effects of gravity on the quantum field. What does that mean, you ask? In essence, it signifies how gravity, a fundamental force of nature, influences the behavior of quantum fields. We are delving deeper into the realm of quantum gravity, a field that seeks to reconcile the theories of quantum mechanics and general relativity. But let's not get lost in the quantum weeds. For our purposes, this modification to the McGinty equation is all about adding depth and complexity, allowing it to account for a wider range of interactions and effects. Now, what about that mysterious G in gravity, XTG? This is a parameter that characterizes the strength of the gravitational force. Just as D, M, Q, and S in the fractal component of the equation help to describe the characteristics of the fractal system, G does the same for the gravitational component. It's a way of tuning the equation to account for different levels of gravitational influence. So the modified McGinty equation now stands as piece lax tt equals sign PSQFTXT plus PS fractal XTDMQS plus PS gravity XTG. It's a more comprehensive model, one that reaches further into the physics underlying our universe. But hold on to your hats, because this equation isn't done evolving. The modification doesn't end there. It even incorporates concepts from general relativity, bringing together the two titans of 20th century physics in a way that could revolutionize our understanding of mental health and the human mind. How does general relativity factor into this equation, and how does it all relate to mental health? This question brings us to the final modification of the McGinty equation, where it's combined with general relativity. This combination represents the perturbative effects of gravity on the quantum field. Here, G characterizes the strength of the gravitational force, adding a new layer of complexity to the equation. Now, let's talk about the self-similar fractal structure, described by the constant parameters V0, L, and S. A fractal is a pattern that repeats at every scale. It's fascinating because it's a mathematical way to describe the natural world. This fractal structure is a key component of the McGinty equation, contributing to its potential for a wide range of applications. To derive the fractal correction term, we dip our toes into the deep waters of integral calculus, Laplace transform, and the convolution theorem. Integral calculus is the branch of mathematics that deals with integrals, especially the methods of ascertaining indefinite integrals and applying them to the solution of differential equations and the determining of areas, volumes, and lengths. The Laplace transform is a powerful tool used to solve differential and integral equations. It transforms a function of a real variable t to a function of a complex variable s. The convolution theorem, on the other hand, provides a major cornerstone for the theory of linear systems, expressing the Fourier transform of a convolution of two signals. Now, how does all this mathematical jargon link back to mental health? Well, these equations, as complex as they are, could potentially be used in creating AI-driven therapy and mental health support systems. They could help these systems understand and respond to individual needs more effectively. The intersection of mental health and technology using equations like the McGinty equation could revolutionize the way we approach mental health care. So the McGinty equation and its modifications hold the potential to revolutionize mental health care, making it more personalized and effective.